Alright, hello everyone. Today we saw in LeetCode 103 binary tree zigzag level order traversal. Given a root of our binary tree, return the zigzag level order traversal of its nodes values, i.e. from left to right, then right to left for the next level and alternate between. So I've copied the example here, and we can think about this tree as having 3 levels, 0, 1, and 2. And for the first level, we'll print out its nodes in left to right, so that would be 3. Second level, we go right to left, so we'd start off with the 20. And then the 9. And for the last level, we switch right back to left to right, so that'll be 15 and then 7. As you can see, this is the exact format that is in the output. 3, 20, 9, 15, 7, 3, 29, 15, and 7. Alright, so now that you understand the question, let's go into how we'd solve it. We're going to need a breadth first search algorithm because we need to traverse this tree level by level. And this is all the tools we're going to need to solve it. First, we have an array. What we're going to use this array for is to append all the nodes values from each level onto this array. The queue is used to append nodes, and we're going to traverse this tree with this queue. So we're going to append each node in each level here. And the res is just what we're going to be appending the levels from array onto. So as you can see, the output is a 2D array. So res is just that encapsulating array that's going to hold all the levels. All right, so let's begin. So we start off always with the root. So we have 3, and we're going to put a 0 here for level 1. So that means we're at node 3, and it has a level of 0. All right, so we traverse the tree, and we're going to say while queue. So while our queue still has elements inside of it, which means that there's still elements to traverse within the tree. First, we pop off this element here, and now we're popped off the 3, and we say, hey, let's append this value to our array. So we append it on, we have the 3. Next, say, does 3 have a left or right child? It does, it has both, so we're going to make sure to append those onto our queue because these are the next nodes we want to process. So it has a left child, so we're going to put 9. And as for the level, all we have to do is add 1 to the previous level because it is 1 level deeper, so we know that whatever its parent node was, it's 1 deeper than that. So if its parent had a level of 0, its child will have a parent level of 1, right? And whatever you do to the left side, we have to do to the right side. So we'd put 20 and also a level 1. Perfect. Now that we've processed this entire level, this node has completely been processed. Now, what we do is say, hey, this array here has all the nodes from the levels. We need to know, are we supposed to append it onto res either forward or in the reverse order? And how do we know that? What we're going to do is say, hey, all even levels will be appended normally, and if it's an odd level, we are going to append in reverse order. This has a level of 0. 0 is even, so that means we're going to append in in regular order. So put our 3 there. All right. Now we move on to the next iteration. So array gets reinitialized as an empty array, and now it's time to process the next 2 nodes. So we're going to process 2 times in our for loop for the 2 nodes we have here. First, we pop off the 9, and we're going to append the value 9 onto our array. We say, hey, does it have a left and right child? It doesn't, so there's nothing to append back on. So we process the next node, pop off the 20, and we make sure to append that value onto our array. And we say, all right, does this have a left and right child? It said it does. It has a left and a right child, so we have to make sure to add those to the queue so they can be processed in the next iteration. So we'll have 15. And as for the depth or level, it's just 1 plus whatever the parent was. So if this was 1, then we want to have 2 for the depth. And we do the same thing for the 7. So 7 and level 2 here. Perfect. All right, and now once that ends, we have our values that are on the current level in this array, and we said this is level 1. Is 1 even or odd? It's odd, so that means we want to append it to res in reverse order. So we're going to put in 20 and 9, right? The while loop will go one more time, and we'll reinitialize array to be an empty list yet again. and now it's time to process the last 2 nodes. So we pop off the 15, and as you can see, these 2 nodes have been processed, and now it's time to pop off the 15, and we see, hey, let's append its value to our array. Same story. 15. Does 15 have a left or right child? It doesn't, so there's no more nodes to process from the 15. Let's go to the next node. So like pop off the 7, and we say, all right, let's append its value to the array. Does it have a left or right child? It doesn't, so that means there's no more nodes to process. Now we say, all right, we have all of the values that are on this level. Is this level even or odd? Well, it's 1, 0, 1, 2. 2 is an even number, so that means we'd append normally. So we'd go 15 and 7. Right? And then the while loop will commence because there's no more nodes to process. Every single node in this tree has been processed, so we'd append or return res. And look, it's exactly the same as the output here. 3, 29, 15, 7. All right. So now that you understand the algorithm, let's get into how we solve or code up a solution like this. The first thing I always like to do is, let's say they give us a binary tree that's completely empty. Let's say there's nothing in the tree. So I'd say if not node, return just an empty list because there is no levels. Next, we want to actually create our res. So res is just an array. It's going to hold all of our level orders. Next, we need our queue. And remember, our queue is just going to be a DQ. So DQ. And it's going to start off with the root. So this is the first value we're going to be taking. And the level, which is going to be initialized at 0. So you see how we had the 3 here. And that's why we had 3 in the first position and 0 as the second position. So that's where we're at in the algorithm. So now that we have our queue, we need a while loop to iterate until the queue is empty. So while queue, so this means while all nodes have not been processed. So once they are processed, this will end. And remember, every iteration, we want to have an array that's going to hold all the nodes' values. So we have to create that, and it's going to be initialized as an empty list. Next, we need a for loop. The for loop, this part that a lot of people get confused on, but I'm going to try to explain it very simply. The for loop goes for the length of the queue. So remember, when we only had one element, just the 3, we want the for loop to run one time to only get the levels on that node. Our queue will at most have the number of elements on the current level. Remember, in the second iteration, it had the 9 and the 20. That means it would loop twice because there's 2 nodes on this level, and then the last level had the 15 and the 7, and it looped twice. It's just to ensure we're only getting nodes from the current level. So I say for, and I use the blank because we won't be using any like variable, in range length of queue. So this will go into the queue, the length of the queue. Now we have to pop off elements. As you remember, when we're here, we have to pop off the elements, the level, and the node that we currently are at. So what I like to do is say node, comma, level equal q dot pop left. All right. So now we've assigned the node and the level onto these variables. Next, what we want to do is say array dot append node dot val. So that's just going to put all of the nodes on the current level into our array. Perfect. Now, this is where we process the children. So how do we process the children? We need to first know if there is a child. So I'll say if node.left. So if there is a node on the left-hand side, we want to q.append node.left. So we're going to be processing that one next. And as for the level, we want to do level plus 1 because it's 1 level deeper because this is a child. Perfect. And remember, whatever we do to the left-hand side, we need to do to the right-hand side. So I copied that line over, and we're going to put right, and instead of saying if node.left, we want to say if node.right to check the right-hand side. So now this is able to append new nodes onto the queue. All right, so once this for loop ends, that means that all nodes on the level have been processed. Now all we have to do is deduce whether we should append to res and normal order or reverse order. So how do we check if the level is even or odd? Well, we could say if level modulo 2 equals 0. So if we divide it by 2 and we don't get a remainder, that means it's an even number. So we're going to say res.append array. Perfect. And if it's not even, that means it has to be odd. So we could just write else res.append array, but we're going to have it in reverse order. So we can use colon, colon, and then the -1 sign. And this will reverse the array. All right. Now, all we have to do is once this all finishes, our res should have all of the levels, nodes values at each level in alternating order. So now all we have to do is return res. And hopefully this should work. Not access local variable node. Apologies. I put node, you're supposed to put root. Let's try this again. Always a small typo. All right, there we go. And we solved the problem and it's pretty efficient. It reached 100% in runtime complexity. So I hope you enjoyed the video. Peace.